According to the National Electrical Code, dwelling units are required to have a main breaker in the load center. This requirement ensures a level of safety and provides a convenient means of disconnecting power to the entire unit. The main breaker serves several important functions. Firstly, it provides overcurrent protection for the entire dwelling unit. This means that if there is an overload or short circuit within the unit, the main breaker will trip, cutting off power and preventing damage to the wiring and appliances. Secondly, the main breaker provides a convenient means of disconnecting power to the entire dwelling unit. This can be useful for maintenance or emergency purposes. For example, if there is a fire in the unit, the main breaker can be quickly shut off to energize all of the electrical circuits. Thirdly, the main breaker protects the branch circuits within the dwelling unit from overloads and short circuits. Branch circuits are the individual circuits that supply power to lights, outlets, and appliances. If there is an overload or short circuit on one of these circuits, the main breaker will trip, protecting the circuit and preventing damage to the wiring and appliances. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years, and it is widely adopted by state and local governments as the basis for their electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an important resource for electricians, inspectors, and anyone else who works with electrical systems. The main breaker is typically located in the load center, also known as the breaker box or panel board. The load center is a metal cabinet that houses the circuit breakers that protect the individual circuits in the dwelling unit. The main breaker is typically located at the top of the load center and is clearly labeled. The size of the main breaker is determined by the size of the dwelling unit and the amount of electrical load that it is expected to carry. The NEC requires that the main breaker be sized to protect the conductors that feed the dwelling unit. The size of the conductors is determined by the amount of electrical load that the dwelling unit is expected to carry. The NEC provides tables that can be used to determine the appropriate size of conductors and overcurrent protection devices for different types of electrical loads. The main breaker is an important safety device that protects the dwelling unit from electrical hazards. It is important to make sure that the main breaker is properly sized and installed, and that it is functioning properly. If you have any questions about the main breaker in your dwelling unit, you should consult with a qualified electrician. An overcurrent protective device, such as a main breaker, is designed to protect electrical circuits from excessive current, which can cause overheating and potentially lead to fires. The National Electrical Code, specifically Article 230.71, addresses the number of overcurrent devices that can serve as the service disconnecting means. While this section primarily deals with service equipment, the principle of having a main overcurrent protective device is relevant to dwelling units as well. Generally, a single main breaker is preferred for simplicity and ease of operation. However, the NEC does allow for up to 6 service disconnecting means in some cases. This means that a dwelling unit could potentially have multiple breakers that collectively serve as the main overcurrent protection. The purpose of a main breaker is threefold. Firstly, to protect the service entrance conductors from overload. Secondly, to provide a means of disconnecting all power to the dwelling unit for maintenance or emergencies. And thirdly, to protect downstream branch circuits. The main breaker is typically rated at a value that is appropriate for the size of the service entrance conductors and the overall electrical load of the dwelling unit. This rating is usually between 100 amps and 200 amps for a typical residential dwelling. The location of the main breaker is also important. It should be readily accessible to the occupant of the dwelling unit so that they can quickly disconnect power in case of an emergency. It is also important to ensure that the main breaker is properly labeled so that it can be easily identified. The installation of a main breaker should always be performed by a qualified electrician who is familiar with the requirements of the National Electrical Code. This will help to ensure that the installation is safe and compliant with all applicable regulations. In addition to the main breaker, dwelling units are also required to have branch circuit breakers to protect individual circuits within the unit. Branch circuit breakers are typically rated at 15 amps or 20 amps and are used to protect circuits that supply lighting, receptacles, and small appliances. Larger appliances, such as refrigerators and air conditioners, may require dedicated circuits with higher amperage ratings. The NEC provides specific requirements for the types of overcurrent protection devices that must be used in different applications. These requirements are designed to ensure that the electrical system is properly protected from overloads and short circuits. It is important to note that the requirements of the NEC may vary depending on the jurisdiction. Local codes and regulations may impose additional requirements or restrictions on electrical installations. Therefore, it is always important to consult with a qualified electrician or electrical inspector to ensure that your electrical system is compliant with all applicable codes and regulations. In summary, dwelling units are required to have a main breaker in the load center to provide overcurrent protection, a means of disconnecting power, and protection for branch circuits. The main breaker should be properly sized, located, and labeled, and its installation should be performed by a qualified electrician. The NEC provides specific requirements for the installation of main breakers and other overcurrent protection devices, and these requirements may vary depending on the jurisdiction. The main breaker's function is essential for electrical safety in a dwelling unit. By interrupting excessive current flow, it prevents overheating of wires and connected devices, reducing the risk of electrical fires and equipment damage. It also provides a convenient way to energize the entire dwelling for maintenance repairs, or in case of an emergency such as flooding. A main breaker is typically a two-pole breaker, meaning it interrupts both hot wires in a 240-volt circuit simultaneously. This is important for safety as it ensures that all power to the dwelling is cut off when the breaker trips. The rating of the main breaker should be carefully selected to match the service entrance conductors and the expected electrical load of the dwelling. Oversizing the breaker can be dangerous, as it may not trip in the event of an overload, potentially leading to overheating and fire. Undersizing the breaker, on the other hand, can result in nuisance tripping, interrupting power unnecessarily. Licensed electricians use specific calculation methods outlined in the NEC to determine the appropriate breaker size. These calculations take into account the square footage of the dwelling, the number and type of appliances, and other factors that contribute to the overall electrical demand. The NEC also specifies the required working clearances around electrical panels and equipment. These clearances ensure that electricians have enough space to safely work on the electrical system. Obstructions such as storage boxes or furniture should not be placed in front of the electrical panel. Regular inspection of the electrical panel is also recommended. Look for signs of damage such as rust, corrosion, or loose wires. If you notice any problems, contact a qualified electrician to investigate and make repairs. It is also important to keep the panel door closed to protect the breakers from dust and debris. Electrical panels and breakers have a limited lifespan. Over time, breakers can become weak or fail to trip properly. If you have an older electrical panel, it may be a good idea to have it inspected by a qualified electrician to determine if it needs to be replaced. Replacing an outdated panel can improve the safety and reliability of your electrical system. In addition to the main breaker and branch circuit breakers, dwelling units may also have other types of overcurrent protection devices, such as fuses. Fuses are similar to breakers in that they interrupt the flow of current when it exceeds a certain level. However, fuses are typically single-use devices, meaning that they must be replaced after they have blown. Breakers, on the other hand, can be reset after they have tripped. The NEC provides specific requirements for the use of fuses and breakers in different applications. It is important to follow these requirements to ensure that your electrical system is properly protected. Ground fault circuit interrupters, or GFCIs, are another important safety device that is required in dwelling units. GFCIs are designed to protect people from electric shock by quickly interrupting the flow of current to ground. GFCIs are typically required in bathrooms, kitchens, and other areas where there is a risk of water exposure. Arc fault circuit interrupters, or SIs, are also becoming increasingly common in dwelling units. SIs are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. SIs are typically required in bedrooms and other areas where people sleep. The proper installation and maintenance of overcurrent protection devices is essential for electrical safety in dwelling units. By following the requirements of the NEC and consulting with a qualified electrician, you can help to ensure that your electrical system is safe and reliable.